Okay, good day. Welcome to today's lesson. So today we'll be talking about integration in polynomial and differentiation in polynomial, and we'll see how we'll solve some questions under integration. So I'll start with integration. We all know that integration is the area under the curve or area of the polynomial function. So first I'll start with my function. So I'll go to the input field. Enter my function. My function is 2 minus x squared. 2 minus 3x squared. That's my function. Yeah. I think it's loading. Yeah. We have it here. So let me zoom it a little bit. So this is my function, 2 minus 3x squared. So first, let's try and enter an interval. So with that, I need to do that. I have to enter integral, type integral, then I'll do this. My function is f, and my start value. So for now, I'll be dealing with, let's say, negative 0.5, and my end value, x value, will be 0.8. Okay, do that. Okay, this is what we have. So the area under this curve covered by the range negative 0.5 to 0.8, we have 1.96 as here. Okay, again, with this, I can still create some points on the x-axis in such a way that those points will only move along the x-axis. It won't go beyond or below the x-axis. So I'll go to point, select point, have it there, and I click here 2 times. Okay, let's see something. When I move my mouse, you can see that point only move on the x-axis. Okay, we do the same thing. Okay, so I can go back and edit my equation. So now I double click on the area A. Then you come here. Then where we have the negative 0.5, you type x. The point is A. That of the second one, we have B. That's x, the bracket capital B. You have that, you only press OK. So now we can move out our area. So anytime we have A and B, the range when it goes like this, you see that it's positive. Yeah, the area covered is positive. Okay. You know, area is always positive. Okay. So now I have this. I need a point on B to be located here in such a way that whenever I move B, the point move along with B. So I'll come to the input field, open a bracket, then which the point I'm going to use is point B. I'll do that here, and then comma A, small letter A. So you have my point there. So I can decide to change the color, or let's keep it black. Okay. So let's see what happens when we move B. When you move B, you can see that the C moves up and down, up and down, up and down. Okay, let's see what happens when I move A. You see that only moves at the same position, up and down. But you see that the B, it moves along the x-axis, but in an up and down column. So let's on the trace and see what happens when I move B. So this is my point. The trace is on. If I do this when I move it, see what happens. Wow. Okay. Let's see what happens if. So let me turn on C now. Off the trace. Let me off the trace. Okay. Okay. let's see what happens when I move A. And okay, so now I want to on the trace, but I'll change the color to different color. Let's say I use blue. Okay. Let me move my B again, see what happens. So you can see that when you move B, it happens. You can see that it looks like a curve. Is that not it? So we all know that when we integrate a quadratic equation, we get a cubic function or polynomial with degree 3. However, I can also say that. Okay. So now let me off my trace. So now let's try and use the locals and see what will happen. Locals or not. C and B. Okay. I have this. So whenever I move B, let's pick the point. Whenever I move B, you see that when C move along the curve, okay, let's try and add this small. Okay, so when I move my B, you see that my C move along the curve, but when I move A, my curve move up and down. You see that it goes up and come down. Okay, that's the effect of A and B in that locus. Okay, now I can hide my locus. I'll hide my locus. Okay, now I can find my what minimum point or the maximum point in this function. Okay, so with that I can type minimum of function f. That's all. The start x value will be x capital E in the bracket, and that's all. The end x value will be what x capital B capital. You have that when D. Okay, that's our minimum value. Our minimum value. So let's think of what will be our maximum value. That's our minimum value. So you see, when I moved it, that's our minimum. You see that it increase and decrease. So D is our minimum value. And let's take our maximum value of the same function. You enter the same function. You have the x and a capital E, and that of x of e. So our maximum value is what? Y equal 2. That is the y-intercept. That's our maximum value. Okay. So now we can type it. That's how to go about finding the minimum and maximum value of the k. Okay. There are some things that I would like you to know. And you can also use other form of finding area under the curve. Yeah. Let me hide the area below the curve. Area under the curve. Okay. So we have the lower sum. Let's try and find our lower sum. Lower sum. We have x, and that of our start value is x power c and x power b. The number of rectangle we want n. So we're creating a slider automatic. So that's what we have. The lower sum. That's what we have. Okay, so let's put this our curve here. Move this one to the extreme end here. Okay. Yeah. So now we can edit our slider. 100. So what do? Still loading. Okay, let's wait for it. Still loading. Okay, now we have it here. Our slider. We have our slider here. So the minimum value should be 1. The maximum value should be what? 100. And our increment should be what? 0.01. Okay, let's see what happened. Okay, now we have that. So let's increase it and see what happened. Wow, see that this 100 rectangle is under the curve. So now we have 59 to what? 1. That's 1, 2, 3, 3, and so. Okay, and yeah, okay. From here we can still rename it. So go to object property, and that is go to basic, type, copy, go to this side, copy, paste it here. To name that value our lower sum. Let's work on this one. This one will be area, type area. That's area. This one will be, go to object, take this, copy, paste, do that. We have our lower sum. Okay, so we have our lower sum, so we can still hide it. Now let's go to our upper sum. Upper sum. To find the upper sum, we enter the function which is f. Then our x, start x value is x, capital A. Then n x value is x, capital B. Then number of rectangle we are using n. Okay, so that's our upper sum. So let's move it and see. Wow, you see that this upper sum, this is how it will look like. This is our upper sum. Okay, so you can even rename this one also. And go to basic, only copy the upper sum. Then you name it here. And you do that. So that's your upper sum. You have the upper sum. Okay. Okay, we have it. So I can hide my sheet. Okay, that's upper and lower sum. So this one we have the upper sum there. This is our upper sum. And the upper sum is 2.21. Whilst our lower sum is 2.14. And that of area under the curve is, so I would like to change their colors that differentiate them. Let's use different colors. That's lower. Then upper. And have this. Okay. We all know that this color for this color for that. Okay, so we move on to tra P trapezoidal sum, trapezoidal sum. Now one enter our function, and our start value is x into bracket capital A, and our end x value is x into bracket capital B. The number of trapezoids will be what? What do you think? It will be n. No, you get it. So you do that. Okay, you know why? Because our S here has been capitalized, so it's small, it should be small. Okay, when you do that, you have this. Okay, let's see what happens. when I reduce it. The trapezoid will be formed within the case. So trapezoidal sum. So when you add the upper and lower sum, let's add the upper and lower sum. I'm using the calculator. Then we have 2.14 plus 2.21 give us what? 4.35 divided by 2 give us what? 2.17, approximately 2.18. So there's one place. So we are running into 2. That means we are right. So when you add the lower sum and the upper sum and divide by 2, you get what? You get your trapezoidal sum. So this is our trapezoidal. So we change the name to trapezoidal sum. You do that so that you know what you are doing. So that side, change the color. This one can be okay. Let's use red for this one. Right. So that is that. We do that. We have this. So you can see that there's a relationship between what trapezoidal sum. Okay. So you have the area, and you talk about the area, and the curve. Talk about the lower sum, the upper sum, and trapezoidal sum. It gives the accurate or approximate value of the area under the curve. Okay. Now we've learned about all this. So we move on to something. Okay. We all know that all the points that we created on the graph, we need to join them with what? All the rectangle that we created on the graph, we need to join them with points at the lower and on the curve, at the lower x value. Wherever they meet at the x value, we must create a point for them. And when they meet on the curve, we have to put a point there to indicate where they meet. So to do that, what do? You do what? You go back and work on what? Bring a sequence. You can decide to bring a sequence. You can type sequence on the input. You have that. Then you have this. So let's start x value enter. And you do that, you enter your point. And that of the nx value of b, the increment. What do you do? The increment now one do x bracket b, b minus x into bracket a. This is something here. The x is being capitalized, so you have to change it to. And all this divided by n, you close the bracket. Yeah. You see, the problem here, our x should be small letter. You do that, you have this. So these are sequence. So how do we indicate those points? So I want to indicate the point that will join the line AB. So to do that, I'll open a bracket, L1, comma 0. When I do that, you could see that we have all the A to B have been divided into 100 parts, so I'm reducing it. Let's see, okay, this one, we have 40.4, so it has been reduced to 40.4. So all these points will help us to join the rectangle or the trapezium on the curve. So the other one too, you can make use of what? I want to create that same point on the curve. So what do? I open a bracket and type L1, comma, into bracket F, into bracket F, into bracket L1. You do that, you have see that all these things will join the point for me. Okay. So at the same time, you can see that our A and B will move along the x-axis. You see that. Okay, let's find our rectangular sum. Rectangular sum. Let's see something. Rectangular sum. F. Start x value. X value x into bracket E. That of x into bracket B. Number of what? Rectangle. And position of rectangle. So now I'll put it at 0 for now. So we do this. So let's try rename. So go to basic. Now you know what you are doing. Have this rectangular sum. You do change the color. Okay? No, but it's already been there. Okay. When okay. So for rectangular sum we have that. So let's see. So you could see that rectangular sum and trapezoidal sum are the same. You have but you could see that the lower sum and the upper sum give us different figures. And you could see that area under the curve give us 1.6. The trapezoidal sum also give us 1.6, and rectangular sum also give us 1.6. So this trapezoidal, the area, and the rectangular sum give us what? The approximate value of the area under the curve. Okay. So we'll continue and let's see what happened. So we have this of point 2. Let's try and integrate the function. So now let's integrate the function. After do that, we have this. So decide to change the color to black. Do that. Okay. This where the so we have the integral. G is the integral of what? F. Okay, when we integrate F, you get G. So now we have G and F. So now let's indicate where the two angle meet. So go for intercept here, and click on the two curves, 1 and 2. We are only taking into consideration the F and G area under the curve. You could see that when we reduce it, maybe we are taking into consideration F and G. Okay, so here I can decide to change its color, right? To create that of G. Also into red. Let's have this, okay. So change down to red. Have this. So we are taking into consideration the F and G. Okay. So we are finding area under the curve. Okay. So we can decide what we do. Say integral. So now we are going to use integral between functions. So the function 1 is what? F. Function 1 is F. Second function G, our x start value. So let's take point F. F say our start value is -1, -1. And the second one, which is the end x value. Our point is G. Our x value is 0.9, 0.59, sorry, 59, 59. And you do that, you have your area. So you have this, that's the area. Area between the curve. That's area between the curve. Do that. Now, yes. Let's say area between. Area between. Just like that. Area between. Okay. So the area between is the area between those two curves. We have this. Okay. So finding area between two curves, that's how we go about it. Okay. We can use integration to solve problems. A practical problem, maybe given question. So now let me deactivate this. Okay. Given this, then quickly go and pick my question. Question out this and come right now. So we have find the area enclosed by the curve y equal x squared, comma x axis, comma x axis between x equal -1 or x equal positive. So let me take this question here. Copy. Okay. Have my text box. I want to keep my question somewhere here. I'll only paste it here. Okay. I have my question here. So so this is what we are going to work. So we'll find the area enclosed by the curve y equals what x squared. Y equals x squared. Okay, maybe let's try 2x squared and y equals squared. Nothing is not a question. So go back. Y equals 2x squared. 2x squared. 2x squared. 1. 2x squared. That was the question. Okay. Okay. Then come here. So here I'll go to index. Here's my paste here, then paste. Have it. Yeah. Try to make it look different. So hold it bigly. Now make it bold, the question bold. Maybe medium. Like I will see. Okay, so find the area enclosed by the curve y equals this. Y equal 2x squared minus 1. And x axis between this interval. Okay, so first I need to create some sliders. Create some sliders. So the slider made first slider A. First slider A. Now name it minus 10. Minus 10 and positive 10. Minus 10 and positive 10. That's the first one. And the increment will be what? 0.01. I have it there. Wow. I have the second one, which is what? B. So say minus 10, positive 10. Increment is 0.01. Okay, I have it here. Okay. Now I need an input box. Okay. First one, I have P. The second one, which is B. Come on. I have it. Let me create another inbox. Input another option. I have this. Okay. A function. Okay. For my function, first let me create my function. So I have my function. My function is what's my function? Function is what? 2x squared 2x squared minus 1. That's the function. Okay. So let me create box for my function. We have our function to go 2x squared. Okay. So with this, let me move things. So this, that. Wow. To move it, just tap on that fixed, right click and tap on fixed object, then you move it to this side. Okay. So let's move this one after. Put this one down. Now so work on it. Size. Okay. Now I have this all my points now. Okay. Now let's have integral. So I'll type integral. Now we have speech. Integral is speech. We have speech. We have that. We'll do that. Let's try to do some. This one will be what? The area between. So the area between. We have this. We are asked to find the area enclosed. Okay, so we'll do that. Area enclosed. That. So we have that. Okay. So now let's try to solve the first one. Let's fix object. Let's use this one too. Fast. Do that fast. Fixed. Okay. So now this equation we are finding the area between the curve y equal to x squared minus 1. The x value are starting from what? X minus x minus 1, or a is minus 1, and that of b is 3. We do that, we have this, the area is what? 14.67. You get it. The area will be 14.3. So the area between the curve from 24 to that, you have that. Okay, what if we have minus 5? Okay, so we can still any range that you have given can be minus 5 and minus 5 and 0. You can see that the area is 78.33. Okay, so this is how we go using this GeoGebra to solve this integral problem. So when you press it, so any value at all, when you enter your interval a and this a and b refers to your x values. Okay, that means you're integrating for a to b of a certain function. This is how we go about it. So today we talk about the integration, how we find the area under the curve, the lower sum, the upper sum, the trapezoidal sum. Also we talk of the rectangular sum, and find the area between two curves using a certain function, and also how to find area enclosed by the curve when given the curve, the function,